Good morning, Veritas. This is the lesson for Tuesday, April 14th, 2020. Hope everybody's doing well. Please make sure that you submit your assignment at the end after watching this video. But at that point, all of your answers should be correct because we are going to go over how to solve these problems right now. So these are the problems that you have for Tuesday, April 14th in your assignments on Google Classroom. So please try these first by yourself. So pause this video if you haven't done these problems yet, and then we will go over them now. And the expectation is that you fix your answers. You ask me for help if you're still not sure how to do anything, and you continue kind of guiding your own learning with a little bit of help from me. All right, so I got a whole blank paper, so get yourself some paper and some space, and we will start with number one. Okay, so number one says, Johanna biked 5,280 feet on Saturday. She biked 1,377 feet fewer on Sunday than she did on Saturday. Part A says, how many feet did she bike on Sunday? What was the total number of feet she rode on Saturday and Sunday? Okay, so first we need to find out how many feet she did on Sunday. Now, when we had a problem like this about a month ago, kids told me that that person biked this number on Sunday. So it was a different problem, but this doesn't tell you that she biked 1,377 feet on Sunday. And a lot of kids just picked that and wrote that there as the answer. This is math, right? You're going to have to do some work in order to get the answer. It's not going to be right there in the problem. So if you just chose that number and put it there, then you really didn't read carefully enough. So let's read it again. Johanna biked 5,280 feet on Saturday. She biked 1,377 feet fewer on Sunday than she did on Saturday. So it didn't say that she biked that many feet. She biked that many feet fewer on Sunday than she did on Saturday. So if we took her Saturday amount, 5,280, it says that on Sunday she biked 1,377 feet fewer or less feet than she did on Saturday. So we're going to start with 5,280. That's how many feet she did on Saturday. And then she biked 1,377 fewer feet on Sunday. So in order to find Sunday, 1,377, we need to subtract that much because it's saying she biked that much less on Sunday than she did here on Saturday. So we're going to take this number from Saturday and subtract this 1,377, and that's going to tell us how much she did on Sunday. Okay? So you can't do 0 minus 7. So you're going to borrow from the tens place. You're going to trade one of those 10s. So you're going to take one away. And you're going to add 10 here. Because like we talked about a few weeks ago, every place to the left is 10 times bigger. So one of these equals 10 of these. So since we can't subtract 0 minus 7, we're going to trade one of these for 10 of these. We're just trading. And this is the same value as it started with. Okay? But now we can subtract. So 10 minus 7 is 3. 7 minus 7 is 0. You can't do 2 minus 3, so again, we're going to borrow 1 from this place value and turn that to a 4. And we're going to add 10 to this place value. So we took 1 from here and added 10 there, so we really didn't change anything at all, right? This is worth 10 times as much as this, so one of these equals 10 of these. So we're just trading. One of those, take away, add 10 of those. 12 minus 3 is 9. And 4 minus 1 is 3. So on Sunday, she took 3,903 steps. Or no, she biked that many feet. So 3,903 feet on Sunday is the answer to part A. We took Saturday. We did 1,377 less than she did on Saturday when she did Sunday. So this is the answer to Sunday. Now it said, what was the total number of feet she rode on Saturday and Sunday? So Saturday was 5,280. 5,280 feet on Saturday. And we just figured out that Sunday was 3,903 feet. So 3,903 on Sunday. Make sure your place values are lined up. Your ones, your tens, your hundreds, and your thousands are in the correct place. We're finding the total, so we are adding these 2 days. Make sure you got the numbers right. 5,280 plus 3,903, and we're good to go. 0 plus 3, just check your operation, make sure you're doing the right one. 8 plus 0 is 8. 9 plus 2 is 11, carry the 1. And then 5 plus the 1 we carried is 6, plus 3 more makes 9. So all together, 9,183 feet is how far she biked on both days combined. Okay? So give yourself some snaps if you got that. I think the most of you will probably, if you messed up, you would have messed up here, and then if you got this answer wrong, then this answer will also be wrong. So it's very, very important to read carefully, because if you just read this quickly, you might have thought that that's how much you wrote on Sunday, but that's not what it says. So you have to really read carefully. All right, sometimes they are trying to trick you a little bit to see if you're going to just read through it quickly and solve it without thinking about it. So you got to just slow down a little bit and work on those word problems. But nice job. If you got that right, congratulations. Okay? Number 2 says to solve. So here's some order of operations, which we talked about in about October. So I'm going to rewrite this over here. That way I have space to work. So 36 minus, in parentheses, 4 plus 2 times 4 equals how much? I'm just going to check I have it right. 36 minus 4 plus 2 in parentheses times 4. 36 minus 4 plus 2 in parentheses times 4. Okay, so we got it right. Now I'm going to solve it here. So we learned earlier this year that the order of operations, we learned a little word called Pemdas. Okay, so basically you do the parentheses first. No matter what is in what order here, no matter what, you're going to do these parentheses first. So we're not going to start with 36. We're going to start with these parentheses. The E is exponents. That's what we will do next. Then you do multiplication or division. These ones go together. Whichever one comes first, moving from left to right like we normally read, you're going to do those. Those ones are kind of together, M and D. And just like addition and subtraction, those ones work together. So whichever one comes first, moving left to right, if it's subtraction that comes first, then you do the subtraction first. These ones kind of are joined together because they're opposite operations. Then these two, multiplication and division, are joined together. Okay? So the reason why we do these first is because these parentheses, that's going to have a huge impact on the rest of this problem. So we're going to do the things that are going to have the biggest impact on our problem first. So first we're going to do the parentheses and then the exponents, because if there are parentheses or exponents, the impact that that's going to have on our answer is going to be the biggest. So we're going to start with those. Then we're going to have multiplication and division. The impact that they're going to have on this problem is going to be big. Bigger than addition and subtraction, because this is repeated addition and subtraction. So we're going to do these first because they're going to have the biggest impact on the answer to this problem. And then the last ones we're going to do are addition and subtraction because those will have the least impact. Okay? So we're going to start with the parentheses. So I'm just going to rewrite 36 minus, because we're not doing this subtraction yet, because that's way down later with the addition and subtraction. We're doing the parentheses first. 4 plus 2 is 6. And then I'm just going to rewrite the rest of it. So 36 minus, the only thing I've done so far is that 4 plus 2 is 6. So we have 36 minus 6 times 4. Now if we look at the order of operations, PEMDAS, we're not going to do this subtraction because first we have to do the multiplication or division. So we're not going to do this subtraction yet. If you did 36 minus 6 is 30 times 4, your answer is wrong because you did in the wrong order of operations. So we're going to do this multiplication next. So we're going to leave the 36. We're going to do the multiplication before we do that subtraction. So 6 times 4 is 24. Now we have 36 minus 24. And since there's only subtraction left, now we can subtract 36 minus 24. If you don't know your facts, you can just subtract. It is 12. So the answer to this problem is 12. If you got any other answer, then you did the operations in the wrong order. You have to do the order of operations in this correct order. Parentheses, exponents, multiplication and division, then addition and subtraction are last. And if you did them in a different order, you would have gotten the wrong answer. So 12 is the correct answer for number 2. So if you did not get 12, I want you to go back. We're going to try more of these because we haven't done these in a while. You got to be really careful about what order you are doing those operations in. Okay, so write this PEMDAS down and keep that somewhere handy with all your papers nice and organized so that you can use it when we do it again tomorrow. Okay, flipping over my workspace, give myself plenty of room for number 3. You guys are doing great, so give yourself snaps. If you got 12 on that, great job, because we have not practiced that in months. So great job. Number 3 says compute. Again, like yesterday, we're going to give you these fancy words that just mean to solve and to see, is that going to trick you, right? Some kids get to there and say, well, I don't know what it means to compute. So just look at it. We're going to add, then we're going to subtract. So even if this is a fancy word you've never heard of, it just means we're going to solve this problem. And they're going to do this on tests. They're going to put words like compute, evaluate. They're going to put words that you're not used to using. You're used to solve, but you're not really used to using this word. That's why we're using it today, is because don't let that trick you. You can still solve this problem. Okay? So order of operation says we're going to do addition and subtraction, whichever one comes first from left to right, because they're the same. So you could do this subtraction, and you could then do this addition, and right? Take this, subtract it, and then add. You'd still get the right answer. But we always like to work from left to right. And since we have addition and subtraction, we can do this in this order from left to right. So we can do 3 2/5. And I'm going to set it up vertically up on top of each other to make it easier when I make equivalent fractions. And we are adding 3 2/5 plus 2 7/10. So before I check, before I work, I'm going to make sure that those are right. 3 2/5 plus 2 7/10. I got the right operation. I got the right fractions. Now we're good to start with that. Okay? So 2/5 and 7/10, we cannot add these yet because they have different denominators. So like I've been saying, we're going to make the smaller denominator bigger, because you can always make numbers bigger by multiplying, but you can't always divide. Like this, we could turn 10 into 5 by dividing by 2, but you can't divide 7 by 2. So we're not really able to do that in this situation. So the way that I teach my kids is to take the small one, and we're going to multiply that one to either get to this number or to get to a number that they can both multiply to. Okay, so this one's already 10, and we know 5 can multiply to get to 10. So we're going to turn fifths into tenths. That way they have the same denominator, and then we can add them. Okay, so you got to say 5 times what is 10? And it's 5 times 2. So in order to make this an equivalent fraction to this, you have to multiply this by a fraction that's equal to 1. So since we have to multiply this times 2 in order to make it tenths, that means we have to multiply this times 2, because 2 halves, 2 over 2, is 1 whole. So we're really multiplying 2/5 times 1 whole in order to make it so that the denominators are then the same to add. So we had to multiply these both by the same number. 5 times 2 got us to the 10 where we need to be, so now we do 2 times 2 is 4/10. So 2/5 and 4/10 are equivalent. We just multiplied it times 1. So we didn't really change it. It just looks a little different right now. Okay? We are adding, so we can do 4/10 plus 7/10 makes 11/10. So that's an improper fraction. Now we'll add them whole numbers. 3 plus 2 is 5. So we have 5 plus 11/10. And like I was saying, this is an improper fraction. That means 11 divided by 10. So over here, I'm going to do 11 divided by 10. If I had 11 markers and I was going to give them to 10 people, right, make 10 equal groups, I can't put 2 markers into each group because I only have 11 and there's 10 equal groups. So I can only put 1 marker into each of those 10 groups. 1 times 10 is 10. That's how many I used in those 10 groups, which gives me 1 left over. All right? If I had 10 groups for 11 markers, I'm going to put 1 in every group, and then I'm going to have 1 left over. So the leftover, the remainder, becomes the numerator of our fraction, and the divisor, the number we divided by, becomes the denominator. So it's 1 and 1/10. So if 11/10 says 1 and 1/10, we have to do 5 plus 1 and 1/10, which is 6 and 1/10. So far we did 3 2/5 plus 2 7/10, and it's 6 1/10. Okay? We had 5 by doing 3 plus 2, but then when we added these fractions, it ended up to be more than 1. So our answer ends up being more than 5. It ends up being 6 because this is more than 1. This is 1 1/10. So 5 plus the 1 1/10 makes 6 1/10. Now we have to do this subtraction. Minus 1 3/5. And then we'll have our answer. So last step. You guys are doing a great job. I'm going to give myself some space here on my work space. We have 6 1/10. And we are subtracting this time 1 3/5. Okay, make sure you got them right. 6 1/10 minus 1 3/5. Don't forget that we are subtracting. Same problem we had earlier. We can't subtract these fractions because they are different size pieces. They have different denominators. So again, we're going to multiply this times a fraction that's equal to 1. That way it doesn't really change the value. It's just going to change the number so that our denominator is 10. So 5 times what is 10? Because we have to get it to 10. That way we can then subtract these fractions. So 5 times 2 was where it needs to be at 10. So we're going to do 3 times 2 times the same number we did down here. That way 2 halves is equal to 1, and we didn't really change this fraction. We just made it look different. We turned it into an equivalent fraction. 5 times 2 was 10. So 3 times 2 is 6/10. Notice we multiplied them both by the same number. And then 3/5 and 6/10 are equivalent. Okay, ready for the hard part? So we have 6 1/10 minus 1 6/10. 6 is more than 1, so this has to be up on top. But we cannot do 1/10 minus 6/10. Because if you had 1/10, you can't take 6 away from that. There's only 1. So here's what we're going to do. We're going to borrow from the whole number. We're going to take 1 away there. And then we're going to add 1 to the fraction. And you're going to use the same denominator. That way we can add them. And we're adding 1. So 10/10 is equal to 1. So we took 1 from here and we added 1 to the fractions. So we didn't really change anything at all. 1/10 plus 10/10 are 11/10. Traded 1 whole. We subtracted 1 from here and we added 1 to the fractions. And now we have 11/10 altogether. Okay, so 11/10 minus 6/10 are 5/10, because 11 minus 6 is 5, and tenths are tenths, and they stay tenths when we subtract. 5 minus 1 is 4, so we have 4 5/10, and we are almost there. The last step we have to do is, since 5 and 10 can both be divided by 5, we need to simplify this fraction. So it's still going to be 4 wholes. We're not simplifying the whole number. We're just simplifying the fraction to make this a little simpler, or the smallest numbers we can possibly use. So if we divide them both by 5, that means we really divided by 5/5, which is equal to 1, and we're not really changing the value of this. We're just making it so that these numbers are a little simpler. So 5 divided by 5 is 1, and 10 divided by 5 is 2. So the answer to this pretty challenging addition and then subtraction problem is 4 1/2. Please go back and slow down this video if you need to, if you got confused at any point, because look at how much work there was here for number 3, right? Lots of steps. So if you're a little bit confused, go back, watch it again, and you can always slow my voice down by putting the playback speed to 75%, and you'll be able to do that then. All right? So give yourself some snaps. Nice work this morning. If you didn't get those right, we'll keep practicing. These are the ones we're going to work on tomorrow, so take a look under Wednesday's assignment. It's about Amelia baking a cake. Be careful, draw yourself a model, and we will take it from there. All right, everybody? Happy Tuesday. We'll see you later. Have a good day.